Welcome back to my channel. I hope everyone is doing great. My name is Raviteja. Let's solve sixth problem of dynamic programming study plan. Problem statement states you are given an integer array nums. You want to maximize the number of points you get by performing the following operations any number of times. Pick any nums of I and delete it to n nums of I points. Afterwards, you must delete every element equal to nums of I minus 1 and every element equal to nums of I plus 1. Return the maximum number of points you can earn by applying the above operation some number of times. Okay. So this problem is more or less similar to the house robber problem. If you haven't watched my house robber problem, I will attach the video link in the description. You can go and check it out, but we'll proceed with this problem. This problem is similar to the house robber problem itself. Okay, so let's say these are the nums we have been provided. Okay, at any given index we have two options, either to delete a particular element and earn those points or not to delete it. Okay, we have two choices. Okay, let's say if I choose to delete the particular element, that means I cannot delete the numbers which are equal to these values. Okay, so let's try to sort this. Okay, will there be any benefit by sorting this input array? Yes, there will be some benefit we will be gaining by sorting it. Reason being, I only have to look in the future for nums of I plus 1. Okay, if I choose to delete this particular number, okay, that means I know so far I have processed certain numbers. Okay, and I only have to look for the future numbers whether I to skip it or skip to take it. Okay, depending upon the choice I am taking at the current position. Okay, if I choose to delete this particular element, that means I only have to look for the elements which is equal to nums of I plus 1 for the skipping. Okay, because I only have to skip the numbers which is equal to nums of I plus 1 and all the elements are in the sorted order, so I can only iterate in this direction and basically skip the elements which are equal to nums of I plus 1. Okay, so let's define a function called f of I which will give me the maximum points n from deleting from index I all the way till the end. Okay, as I mentioned, we have two options, either to take it or skip it. If I choose to take a particular element, okay, let's say in this given input array, if I choose to take 3, okay, that means I have to take all the other 3s, right? And then I have to skip the numbers which is basically 3 plus 1. Okay, so that is what I have written. If I choose to take a nums of I, that means all the elements I have to take which are equal to nums of 3, so which is basically the frequency. If I know the frequency of the current number, then nums of 5 times frequency will tell me the points I gain by taking all 3s, let's say. And we have to also get the problem for the remaining array. So we have to find an index j such that has to be smallest and it has to be greater than nums of 5%, because if I take 3 I cannot take 4, so I have to find a smallest index such that the number which I get should be greater than 4. Okay, let's say I have 3 4 5 6. Okay, I have to see, if I delete 3, that means I can only take 5. Okay, that means I have to find the smallest index such that it is greater than or equal to 3 plus 1. Okay, greater than 3 plus 1, basically not equal to. So that is what I am doing. We have to find the smallest index j such that nums of j is greater than nums of I plus 1. Okay, this is for taking. If I choose to skip it, that means let's say I have 3 3 3 4 5. If I skip 3, that means I have to skip all the 3s which are present over here. Okay, and then only I can take 4. Okay, so I have to find the smallest index j such that the nums of j is not equal to nums of I. Okay, that is what we have to find, and my answer will be coming from f of j basically. Now what is the base case? If there are no elements in the array to consider, that means the number of points you gain is basically 0. Okay, if you draw the recursive diagram, tree diagram for f of I, you will notice that the certain states will be repeating, so we have to implement the dynamic programming solution. Okay, so let me show you the top down approach which I have implemented. Okay, so as I mentioned, f of I is a function which will tell me the maximum points you can earn by considering the array from I till all the way till the end. Okay, so if I let's the first piece of code is basically for the skipping. Okay, so if I have 3 3 3 and 4, I have to skip all these numbers and basically take this. So that is what I'm doing. As long as my j is equal to nums of I will be skipping it. Okay, I will just increment my I pointer. So the answer for my skip is basically f of j. Now that I know the index j is basically pointing at 4 now. So the frequency of 3 is basically j minus I. Okay, so that is what we indirectly identify the frequency also. So if I have to take 3, that means nums of I times its frequency plus I should find an index k such that it is greater than nums of I plus 1, right? So as long as what we are trying to do here is basically, let's say we have 3 3 3 and we can also have 4 4 5, right? So I should also skip these numbers because I have considered 3, that means I cannot consider 4, right? So I have started my k pointer over here and I am going all the way up to 5. Okay, so that is what this part of code is doing. As long as my 4 is equal to 3 plus 1, I will increment k. Okay, where k is pointing to the starting, right? So this way I can identify the first index which is greater than nums of I plus 1, right? So this will give me answer for take. In the end my answer will be maximum of both take and skip. Okay, so as I mentioned, this problem will have certain repeated states, so we have to implement DP. So I just defined a global a DP array at the class level, and then I instantiated it with size n and populated it with -1 value, stating that the value is -1, the answer to the particular state is not calculated yet. Okay, so if the answer to the state is already calculated, that means I have to return it, or else I will compute the answer and store it. So let's try to submit this problem. You will notice that all the test cases will be passed and it will be a pretty efficient solution. Okay, so before dive into time complexity analysis, I highly recommend you to subscribe to my coding channel. Okay, so that you won't be missing content which I will be posting on daily basis. I am doing daily Leetcode problems and posting it, and I also started the DP series where I have already solved all these problems so far. You can also find out the playlist on my YouTube channel. Okay, and I will also attach the link for the playlist in the description as well. So let's try to analyze the time complexity. As you can see, we are populating this DP array with its answers. Okay, so the time complexity is basically time taken to fill all these values, which will be order of n, and the space complexity is also order of n because we are using an extra space of size n. Okay, so that's all about this problem. Hit the like button and hit the subscribe button, and also share your valuable feedback in the comment section. Thank you.